Day 694 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2423, remove letter to equalize frequency. The difficulty level is easy, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero-index string word consisting of lowercase English letters. You need to select one index and remove the letter at that index from word so that the frequency of every letter present in word is equal. Return true if it is possible to remove one letter so that the frequency of all letters in word are equal, and false otherwise. Note: the frequency of a letter X is the number of times it occurs in the string. You must remove exactly one letter and cannot choose to do nothing. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So, in example 1, we have our input word equals a string A, B, C, C. The output is true. Explanation says select index 3 and delete it. Word becomes ABC, and each character has a frequency of 1. So, let's break this down one step further, right? We have this string. We want to return true or false if it is possible to remove one letter or one index, right? We cannot remove two letters. We can only remove one letter. It says right here, if it is possible to remove one letter so that the frequency of all letters in word are equal, false otherwise. So if let's copy and paste this, boom. So if sorry y'all, if we have, say we remove one letter, boom, we remove this C. Now every character in this appears once. A appears once, B appears once, C appears once. Since they all appear once, that means their frequency is the same, right? It says the frequency of a letter X is the number of times it occurs in a string. So they all appear once. A, B, and C all appear one time, so they all have the same frequency. And since we were able to achieve this by only deleting one character, which was this C, then we can return true. Now let's take a look at example 2 where it's not possible, right? So in example 2, we have an input word equals a string AAZZ. This time the output is false. It says we must delete a character, so either the frequency of A is 1 and the frequency of Z is 2, or vice versa. It is impossible to make all present characters have equal frequency. So remember, we can only delete one character. So even if we delete one Z, the string is still not equalized, right? The frequency is not equal because there's two A's and one Z. But say we delete one A instead, then the frequency is still not equal because now we have one A and two Z's, right? So either way, we're either going to have two A's and one Z, or one A and two Z's, and the frequency will never be equal. So the output is false because remember, we can only delete one letter, no more, no less. Boom. So now that we understand the question, let's get into the fun part, the actual solution. Solution's not that difficult. Now, first thing we want to do is we're going to create a dictionary to count the frequency of each character. So we'll declare a variable called C, and we'll set that equal to a dictionary of characters. So we'll say open up the square bracket, say character colon, then the value is going to be an integer, so and put the parentheses like this. Now we need to count how many times each character appears in words. So we're going to say for char in chars, or excuse me, not in chars, for char in word, we're going to open up the bracket and we'll say C square bracket char, come outside of that, equals, open up the parentheses, C square bracket char, come outside of that, question mark, 0, come outside of that, and we'll say +1. Boom. Now we need a dictionary to count how many characters have the same frequency. So if A appears 2 times and B appears 2 times, we need to check that. So we could come underneath this, declare a variable called counts, set that equal to a dictionary, key is an integer, value is an integer as well, and put the parentheses like so. Boom. Now we need to build the frequency of the frequency map. So we'll say for count nc.values. We'll open up the brackets and we'll say counts, square bracket count, come outside of that, equals, open up the parentheses, counts, square bracket count, come outside of that, question mark, 0, come outside of that, and +1. Boom. Now, for case 1, only one frequency exists. So we'll handle that by saying if counts.count equal =1, we'll open up the brackets and either all characters appear once, so we can remove any one character, or all characters appear the same number of times and removing one full character fixes it. So we'll say return counts, square bracket 1, come outside of that, does not equal nil, or 2 vertical lines, counts, square bracket word dot count, come outside of that, does not equal nil. Boom. Now for case 2, if exactly 2 different frequencies exist, we handle that by coming underneath this and we'll say if counts.count equals 2, then we'll open up the brackets and option 1, that means one character appears only once and we can remove it. So we'll say counts, square bracket 1 equals 1, or 2 vertical lines. Option 2, one frequency is exactly one higher than the other and only one character has that higher frequency. So we'll say counts, square bracket, counts.min, open up the parentheses, by, colon, open up the brackets, we'll say $0 value is greater than $1 value. Boom. Then we'll come outside of this parentheses, we'll say question mark dot key +1, and then come outside of this square bracket and we'll say equals 1. Boom. But we're not done yet because we still need to check if more than 2 frequencies exist, then that means it's impossible. So we could just come right here and we could say return false, y'all. Boom. That should be all she wrote. Let's run it. Give it a run. Make sure it runs properly. Ooh, we got the wrong answer. So that means probably somewhere the math isn't mathing. So let's see if I can find out where the math isn't mathing. Oh, hold on. Nope, that's not it. Thought I found it. Just a minute, y'all. Oh, so this should be a return right here. Sorry, y'all. That should do the trick. Let's see if that did the trick. It's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And got the wrong answer again. So now, let's see. All right, y'all. I think I found what it is. I don't know why does it like this. Maybe it's some type of glitch, but apparently we just have to move this and break this up. There's nothing wrong with the code. It's just how it lines up apparently. So let's give this a run and see if this does the trick. I don't know why it makes a difference, but it does. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.